Hi everyone. Last week I had planned for a session on Kubernetes observability, but unfortunately LinkedIn was not that kind with us. So what happened is like my mic didn't record anything, even though the mic was working, but LinkedIn was not getting the feeds. So I had to cancel the live session, but here I am today doing that session again. This time it's not live. I am recording it and putting it on YouTube, but I will follow the same pattern which I had planned for the live class. So I will start with the problem definition. I will explain. So the topic is on KTS observability monitoring stack of Prometheus, and I will be explaining what is the problem statement, why do we need it in the first place, where does it fit in the conceptual stack of Kubernetes, and then explain the solution propositions that are there in a whiteboard, and then implement the solution uh, on the lab. And of course, whatever I do, the source code is available and you can practice it along with me once you are done watching this video. Okay, then let's start. I'm going to presume as if this is live, okay? So there is no editing and I'm just gonna record it and put it there. So bear with me if there are any editing loopholes or it doesn't sound that fancy. Okay, cool. So let me share my screen. Probably my screen should be already shared. All right. So this was the stack presentation which I had planned for. It was planned for 25th of December, and we had around nearly 600 attendees asking for it, but LinkedIn was not that kind. Okay, so this is the agenda for the session, and this is what I'm going to copy, and let me paste it here in the whiteboard so we don't have to go back and see that again. All right. Let's keep it here. Introduction, the Kubernetes vertical for the operations. Of course, before you start picking up any topic like Prometheus and Grafana, the main actors of our discussion today, these are tools. And before you start picking up any tool, you should know why you are using them or what is the requirement, what is the problem statement. Unless that part is clear, never start using a tool, okay? Unless you are already aware why you need that tool or what is it that you are expected to solve with this. So that's the part that we are going to discuss in these 2 points. First, the vertical of operations. There are actually 5 verticals in Kubernetes. These are conceptual verticals, so you don't find them in books. I would probably put a picture here. I might already have it somewhere. Let me see. Yeah, so I have a picture here. So whenever I start my KRS sessions or whenever I start my uh, KRS classes, the weekend batches, this is the five conceptual pillars that I like to discuss the topics around. And this part of operators, they come somewhere here in custom resources. And I'm going to talk about all of these pillars. And basically, this is your entire Kubernetes in a nutshell. Then a problem statement, of course, that's why we need it, and how Prometheus and Grafana is going to provide a solution for that problem statement. Then we are going to do the setup. Everything that we do is from our repository here, which is called project sessions. And these project sessions are public. This is a public repository. There are multiple sessions based on multiple subtopics, so as to say. And this particular subtopic is part of scaling HPA and Prometheus block, that is session number 6. I will be showing you how to use this setup and how to create the entire lab in your local laptop. You can use anything. I prefer to use Docker Desktop. Then sample application to test the setup. Of course, we need to have some kind of an application which we want to monitor, which should send some logs, which should send some data out to our dashboard, and that's what the application is going to be provided here itself in the uh, Git. And then, of course, the production guidelines for this particular tool and technology. Okay, cool. So let's get started first with the main picture here. All right. So, like I said, there are five conceptual pillars to Kubernetes, and these are conceptual pillars. So, you might not find a hard-code definition of this in your books, but if you look closely, then you can correlate it and you can remember it. And this is, like I said, most of the times my go-to, you know, topic to start a new batch. This gives a good understanding of what we are going to cover to all of the students, and that's what we also need this understanding, because whenever you take a new topic, you should know in which pillar does it fall. Does it fall in computation, networking, storage, security, or custom resources? Because these are the main five conceptual pillars. Let's start with computation. So whatever you are going to build, or whatever you are going to have, you need a computation to, first of all, remember that Kubernetes is only for deployment. You will not do any CI related stuff in Kubernetes, okay? All your microservices which you are going to deploy, first they have to be converted into a Docker image. That image has to be converted into a container. That container has to be converted into a pod, and pod is like the atom, the smallest element which the Kubernetes is going to manage. And Kubernetes, this is an example I like to give. Think of Kubernetes as your assistant, and this guy is going to follow the instructions, the commands that you provide in terms of rules and policies that you define. And it has certain guidelines and it has certain pillars, and these are the pillars. The main one being computation, because whatever you have developed, the pod is going to be the first guy who is going to be, like I said, it is the atom of our computation, but it doesn't start with the pod. For a pod, you need to have a container image, and for a container image, you need to have a container definition file, generally a Docker file, and for that, you need to have a microservice. You don't start from microservice in Kubernetes, we directly start from pod level. So all our computation, they sit in this conceptual pillar. You have pods, and then pods are managing your microservices. You have deployments, which are managing the pods. You have stateful sets, again, they are managing the pods. You have jobs, cron jobs. So you might have, read about these subtopics or these, let's say, topics in different ways, but they are all there to manage and to assist you with your computation. Remember, I said that Kubernetes is your assistant, and computation assistance is provided by these Kubernetes native objects. These are all native to Kubernetes. Kubernetes understands what's a pod, what's a deployment, what's a stateful set, and I don't I'm not going to go too deep into understanding the lifecycle hierarchy of these object correlation with one another, but just remember that pod is the smallest element. For a pod to work, you need to have a Docker image. For a Docker image, you need to have a Docker file. And of course, for a Docker file, you need to have an application. And then managing the pod as deployment, managing the deployment are controllers. And like that, you have cron jobs, daemon sets. These are all certain objects of Kubernetes which are there to help you with computation. Cool. Then side by side with computation, there is networking and storage. Because if you have a computation in you have if you have a pod and you want to expose it to outside world without networking, it's not possible, right? And of course, your pod also needs some kind of storage. So networking and storage are the helpers for the computation, and networking pillar consists of services, slashing, ingresses, network policies. All are again native Kubernetes objects. All right, so there is no concept of networking without the computation. So that's why we start first with the computation and then we provide networking and storage to it. Storage, all your volumes, your storage classes, your PVs, PVCs, dynamic volumes, those are all part of the storage category or the storage conceptual pillar of Kubernetes. Then heading storage, computation, and networking is your security. This is required for all the verticals of the other pillars. So that's why you see that it is horizontally present on top of storage, computation, and networking. This is where you will have your service accounts, your PSPs, your secrets, your roles, and other policies related to security. Fine. So we have our computation, we have our networking, we have storage. To manage them all, we have security. But what about this topic of ours that is for observability? Sorry, I don't know what I said. Observability. So where is that? It doesn't come native to Kubernetes. And all of the things that don't come native to Kubernetes, they are part of the custom resources. All right. So custom resources are those components which you can, for simplicity's sake, think like there is a team outside of Kubernetes who is working on, let's say, Nginx, who is working on, let's say, um, some Vault operators, some MongoDB operators. Those are separate software teams who have built the software which can be installed on Kubernetes stack. Just like you have a mobile and some of the application to the mobile come inbuilt, inherent. That's why I was saying native. When I said that these are all the objects that are native to Kubernetes, that means when you buy a phone, the calling app, the messaging app, they are native to your mobile. You don't have to install it. But WhatsApp, you might have to install because WhatsApp comes from a different company, which may be your phone. Of course, your phone is coming from, let's say, if it's a Samsung phone, then WhatsApp is a different company, which is from Meta, and Samsung is a different company. So you will have to install WhatsApp on Samsung. So think of custom resources. This is a example that I like to give for just simplicity's sake. Don't go too deep into correlations. So think of WhatsApp as a custom resource which Meta has developed and they have made it compatible with Samsung. Think of custom resources, like there will be multiple applications like that, Play Store kind of a thing, where people have developed their applications which are not native to Kubernetes inherently, but they have built them in such a way that they can be installed on Kubernetes. And that is where our monitoring, our logging, and all our observability tools sit in. They are not native to Kubernetes. So if you start a pod and you want that the log of this pod should be managed in some kind of a structure, some kind of a dashboard, it doesn't come inherently. Kubernetes does not give that facility and feature. And that is the problem statement that we are trying to adhere to, or that we are trying to address with Prometheus and Grafana. Once you install a application, once you run a software on Kubernetes, you of course need to watch it for any issues, any problems, right? There are two different things which are like subtopics to observability. I'll talk about them, but let me just finish the custom resources definition. So custom resources, some other teams, just like WhatsApp in our case of mobile, has developed a solution for Samsung mobiles where Samsung mobiles can now support WhatsApp. Like that, custom resources, there will be multiple custom resources. And when you are installing a custom resource itself has 4 to 5 sub objects. Like these are the objects of Kubernetes. A pod is an object, deployment is an object, stateful set is an object of Kubernetes for computation, for networking ingress, network policies, endpoints, storage classes, volumes in storage hierarchical. Like that, for custom resources, there will always be a custom resource definition, a custom resource object, then a controller managing the custom resources, admission controllers, and webhooks. You don't need to go deep into this for the sake of this particular session, but I have given a different class altogether on custom resources. If you're interested about it, go into my LinkedIn page and see for a recorded session on custom resources. I think it's a one hour hands-on lab where I have explained this in detail. So I'm going to skip and move ahead. All of the observability related tool like Prometheus, Grafana, and all of that stack, they fall into custom resources. You have to install them to make them work with your native cluster. When you set up a cluster, they don't come by default. All right. And now, why do we need them in the first place? We need them. Let's say I'm a user and I'm a user of Kubernetes, or I'm an administrator of Kubernetes. I've installed an app there. I am not going to continuously go to the console of Kubernetes and see how my app is performing. Put some load and come back and see how it is working. It's not scalable. It's not possible. And then, of course, it's not going to work in production states. We need to have dashboards, we need to have alerts, we need to have monitoring systems in place. And for those guys to work, we need to install custom resource objects of those applications which support that kind of feature. I have installed Nginx, for example, and my Nginx is hosting my website, and I get a load of, let's say, 10,000 users, and my website starts degrading or starts throttling or starts throwing me some errors, or maybe I have a horizontal pod autoscaler in place and then it's not working properly with the CPU utilization. All of these are key points that I need to be made aware of. And remember, I said Kubernetes is my assistant. It's the job of my assistant to notify me. But if you do not have these tools, it cannot notify me. So it will directly be the customer shouting on my head because they will definitely for sure see it in their live environments. So think of it like I am in a meeting and I tell to my assistants, okay, I'm going into a meeting, don't call me and don't disturb me unless this is a call coming from my mom, right? Then you have to disturb me, then you have to get me back. That condition is a rule that you are setting for your assistant, and those rules cannot be natively set for observability in Kubernetes unless you have tools that understand it. All right. So there are tools which only understand the rules, and there are tools which also understand the rule and then present it in a dashboard. So Prometheus is the guy who will understand the rules, and Grafana is a guy who will present it in a presentable way in a dashboard as a solution for us. Anytime my website is throttling, anytime there is a problem in my network or in my stack, in my computation stack, maybe in my networking stack, it depends on what kind of rule that I'm setting. I will be notified and then I will have to take corrective actions. All right. So that in a nutshell is what our problem statement is. And we are going to set up the lab now. And hopefully you will be able to practice the session along with me. Once you understand the problem statement, it will be easier for me to actually introduce a problem and show it to you. And then also we are going to see the dashboards, and we are also going to see some custom rules, just like, for example, say whenever there is a load on my website, and let's say my website gets to 50% load, you notify me. So I want an alert to be triggered to me whenever the load is more. So I will create a dummy website and generate dummy load on it, and then I will have my custom alerts put in place. I will have my dashboards put in place, and then we will see how that will work in practice. All right, so let's get started with the setup. I'm starting my Kubernetes setup. Oh, my present working directory. I need to go one step back. One more. Like I said, this is from, let me zoom it a little bit. So this is from the project sessions repository, and this is from session number 6. And I'm just going to follow the setup which is provided in the README, and I have checked in the code, and Here is my work directory. Okay, so let's go to session 6. Now, of course, in order to do the entire hands-on, uh, you would need to have the images because you need to have a dummy application where you will test all of this, right? So I have provided hopefully the image before running the deployment. Make sure, yeah. So I have given the instructions that make sure that the images are present. I'll also show you how to create them. You have to go to session number 2 here. So CD2 session 2, and there go into part 2, right? And just do a Docker compose build. That's all you have to do to create the images. Okay, it will create the necessary images for you. I probably might already be having them, but I will check them any which ways. If I don't have, then I will also create them. All right, so I have them. Uh, yeah, I have them. I don't need to create it, but you can create it from session number 2. Okay, so let's go back to session 6 for our observability. Uh, I forgot to say one thing. So remember I said like there are two parts to observability. So observability is considered to be divided in, this is like again a very vague definition, so don't grab me by the rule for this. It has two parts. One is the logging part and another one is the monitoring part. By the definition of observability, you want to understand or you want to observe what is happening with your applications. And there are two things to it. One is that whenever a problem comes, you can debug the solution of that problem by looking at your observability solutions, either your logging or your monitoring. These are two children of observability. But there is another thing. So one is a preventive action and then one is a reactive. So debugging is a reactive action, and preventive action, for that also you need to have observability. For example, preventive action is one that I'm going to show here as well, which is called scaling, auto scaling, right? So you prevent throttling from happening based on the controller object for scaling. So in our example, I am saying that, okay, I don't want my throttling, my website to throttle. Instead, I want it to scale. So this is a preventive action. I'm not reacting. Reactive is more or less like there is a bug that has been reported and now you want to go back and see what happened in the logs. For both, you need to have observability. And remember, observability comes in two parts. One is logging and another one is monitoring. Logging is not what we are covering here. Logging is your ELK stacks, your gray logs, your fluent bit, your fluent, maybe some in some other class I'll show you how that is also done. Logging is not what we are doing. We are doing monitoring, the dashboarding part here. Logging cannot help you with prevention. Okay, that's the key thing here. Logging is only for record and bookkeeping. Alerts and throttling information and notification custom rules, those can help you with prevention. So that's a very good interview question as well. If you think about it, if you do not have your dashboards, your alert mechanisms, and your monitoring rule or your custom rules, you cannot have in principle, you cannot have a auto-correcting or a preventive system in place. So if anybody asks you an interview question, make sure that the question might be like, okay, what are the preventive measures that you have set up in your Kubernetes cluster so that the problems don't come in production? So thank me later if that question comes. All right, so let's follow the README. We are going to first apply. I'm just going to follow the commands as is. Wow, nice. Did my Kubernetes start? Okay, I just had to reset my Kubernetes cluster. So we are back. Let's go to my folder directory, documents, not personal. I want to go to workspaces and then our project sessions. Right, so here we are, session 6. In a way, this is good because I had to reset my cluster. So basically, I will have to do entire setup, and I might also have to do the metric server setup. So let's see if that is there. Get pod hyphen n cube system metric server. Where are you? It's not here. Good. Get namespaces, and monitoring is also not here. Good. So I will basically be doing everything from scratch, and that is a good thing for you, not a good thing for me. All right, so we are going to deploy one application. Like I said, we need a dummy application. So that's the dummy application, and then I'm going to deploy one service. So this is the application is the what I deployed here. Application, this is the compute that I was talking about. This will fall in the compute, and then I deployed the service, and the service will fall in the network. All right. And that's how you should also correlate whenever you are deploying anything in your cluster. You should correlate and try to visualize where does it fall in which logical pillar, because it will then help you understand the correlation of its calling structures and APIs. All right. Then we go and we create one dummy pod for testing. This we need for later, not now. So we should in total have 3 pods. That's what we have. And then in order to test whether my dummy application is working properly or not, I would need to exec into Nginx. Oh, sorry. And then curl it. So this should basically be able to talk to my, yeah, so it's able to talk to my application, and this is the simple output that I'm getting from the application when I'm hitting it on an API at the port 80. Cool. So this is my prerequisite. I also need to have metric server. Let's see if I have given the installation for that. Before running the HPA metric server should be installed. Yes. Apply. Okay, good. I have, seems like, given instructions for that. So let's follow that instruction. Apply minus F. Okay, I'm directly following it. Right. So this is installing a lot of metric servers, installing a lot of Kubernetes components. Now, some of these components like service accounts, cluster role, these are security components. Some of them like services, deployments. Services is again a monitoring component. Deployment is a compute component. So like this, you can later on correlate whenever you are installing something. You can understand if I am installing something in which logical pillar is this going on. Okay, so there is I think I have to give a TLS flag here, right? Yes. Otherwise, this metric server doesn't work. Get pod hyphen n cube system metric server. Are you running? No, it's not running. So what I'm going to do is I am going to edit it with the changes that I have mentioned here. So this is part of the deployment, kube namespaces, and then we will go to kube system, and there we'll say get deploy, and we are going to edit this particular guy because as you see it's not in a ready state. So k edit deploy, and what we have to edit is argument to this metric server, so that I say to it that you do not need to give me a certificate in order to take the values from me. Okay, right. So this is the value that you are also supposed to put here in your deployment for making it work, and that should be enough for the pod to stop misbehaving. Okay, it created another one. Let's give it a couple of more seconds. Hopefully it should work. All right. So after a couple of seconds, we are good with it. Now we need these load generators and HPA configurators, but we need it later. So I'm going to do it when they are required, because remember what we are going to, the problem that we are going to give to our system is that we are going to create a website, which we have already created a deployment for that. Let's say not a website, but an application. In this application, we are going to define limits for memory and CPU, and then we are going to generate the load. And when the load is getting generated, I want my observability stack or my Prometheus and Grafana stack to have both of the things in place. One is a preventive mechanism which the HPA will provide me in collaboration with the stack that I'm creating, so that when the threshold is reached to, let's say, 50%, 30%, doesn't really matter, it starts to scale out. But at the same time, it should also give a notification to me as a user, as an administrator, that hey, this event has triggered. I have started to solve it, but I'm just letting you know you can come back and check what is happening. So it will create a custom alert for me, and that custom alert, as an operator or as an administrator of Kubernetes, I should see it in my dash, I should get it in my email. It depends on what kind of configurations I choose. Dashboards are fine. Otherwise, people use tools like Ops Genie for calls and all that stuff. Basically, I want both of the system to be in place. One, I should be made aware, but second, the system should be smart enough to take the preventive or right course of action. It should not wait for me. Okay, so that's why I said it's Kubernetes is your assistant. You have to give it guidelines. I am going to give it guidelines in the custom rules to notify me, but I am also going to give it intelligence to manage this problem without me having to interfere. All right, so I needed to create the problem when I'm doing the HPA, so that's not needed right now. What we will do is we will see whether or not we have Helm first. Do I have Helm? Okay, great, we have Helm. Kubernetes, so let's go back to default. And then what I'm going to do is I am going to, now for the custom resources, I need to install them. Just like for WhatsApp, you need to go to Play Store and install it because they are not available as a native object to Kubernetes. I am going to use Helm for installing the Prometheus and Grafana as a custom resources to my Kubernetes stack. There are other ways to install it. This is the easy way. All right, so let's go here. First of all, let's create the namespace as is mentioned here. So we create the namespace and then we add the repository. Okay, let's add the repository. Already exists, good. So let's update the repository. Okay, nice. And then what we are going to do is we are going to install the custom resources or install the Prometheus. Make sure that you are also installing it as the Prometheus community version, or I don't know how they call it, chart version. Take this chart version. This is the free and the useful one. This will install a lot of components to Kubernetes, just like your monitoring did. And sometimes it takes few minutes, sometimes it takes a lot more than few minutes. It depends on your network speed, so be patient with it. All right, so for me, it didn't take that much time, and if you can see, it gives information of what it has installed, and kubectl namespace monitoring get pod list all will tell you what is the running status, because that running status is required to be the pod is required to be in the running status. And most of the time, this will be, if you're using Mac, then this will have some problems. These are the kind of problems that I have faced with it before, and that's probably why I wanted to highlight this. Because Mac has security related issues, it doesn't allow the volume mounting to happen properly. These are the solutions for this. You have to run those patch commands, but make sure that whenever you are done with it, unless this node exporter is running, nothing in the Prometheus will be running for you. Okay, so let's try to run this command once and see if that resolves our problem. Not found, of course, because the name would be different this time. Node exporter. I should go into that. I should go into that kubectl. That's the kubeNS. I should go into that namespace first. And then run it. Yeah. So let's see. Okay. Node exporter is working fine after that. Remember, if this node exporter doesn't work, because when you are installing Prometheus and Grafana stack, they will install a lot of things. If I do kubectl get, let's say all, do I need to give this? Then you will see there are a lot of things that are getting installed as part of the Helm that you have installed here. The most important part, everything is important, but the most important part is this node exporter. What it means is that Prometheus works on the logic of fetching data. This is a essentially this is a database which works on time series, and it fetches the data from some location. And node exporter is the guy or the pod which is responsible for fetching the data from that particular location, maybe var, log, docker, or wherever you are exporting the log. By default, if this is not working, like I had to patch this particular um, daemon set, and it's a daemon set. So if you're not aware of what daemon sets are, these are also part of the computation stack here, daemon sets. And that's why it helps to have, again, I'm repeating myself, but having this pictorial representation in your head will help you with understanding where does a particular Kubernetes object fit in. It's again a computational object. What it does is it creates a pod in all of the nodes that are going to be part of your Kubernetes cluster. In my case, only one node is there, and hence I am only getting one node exporter pod. Otherwise, if I had two nodes, I would have had two pods for this. And if it doesn't work, it means that Prometheus is not able to fetch the logs from the node. So this is very much needed. All right, then let's expose a couple of services. We need them. All right, so these services are exposed. So what I have done is I have on my vanilla Kubernetes cluster installed my application, and then as a custom resource, I installed Prometheus and I also installed Grafana. My use case is that I am going to put load on my application, which I installed, and I am going to use this Prometheus and Grafana. So I have exposed them as services, as node ports, so that I can see them on the browser. Otherwise, they are already available as cluster IPs, but I need to see them on the browser, so I'm just exposing them as node port. My use case is that I want to understand what is happening in my application based on the contents that are, or based on the events that are happening there. Now remember, for an application to talk with Prometheus, it has to speak the language of Prometheus. What that means is Prometheus is a server, it needs a client. If your application does not have a Prometheus client, then it will not speak with the Prometheus server. All of the major applications that are built today, or let's say all of the programming languages support the client for Prometheus. My application is a Python application that I have created. I have installed something for Prometheus here in this application. So let me duplicate it and let me go to project sessions. Right. So this is the app, or this is the application that we called. Here, if you see, I am importing Prometheus client, right? So this is what I was trying to make you understand, that Prometheus server, which we have just now installed, will require a Prometheus client. If your application, which you want to monitor with Prometheus, does not have the client, then the server does not work. Okay, so keep that in your mind. If you want something like my application should notify the Prometheus server on the custom rules and alerts, it needs to speak to Prometheus server so that Prometheus server understands its language. Those are called Prometheus clients that need to be present. So Prometheus server basically scrapes the clients. It's like a heartbeat that is sent to the server, and based on that heartbeat, there is a sequence in which it is sent. Based on that heartbeat, it evaluates the health, and evaluates the values from the client. If you have an application which has a Prometheus client, then use your application for this practice. Otherwise, use the one that I am creating. But remember, you cannot just randomly take any application and then expect Prometheus alerts to work. It will not work, because server needs a client, and client needs to communicate its status to the server in a language that server understands. Okay, and having the Prometheus client is not that difficult. Like I showed you, it's just an import that you have to do, and all the major programming languages, they have this. All right, so let's move on. And we exposed get svc. So I exposed Grafana load balancer and Prometheus load balancer. Prometheus is working on this particular port. So let's go and check this one out. 688 Okay. Localhost 32688. Awesome. So I can access my Prometheus URL now from the node port that I created. And Prometheus, this is how it looks like. Maybe in your case, it might look a little bit different. This depends on the theme that you select. And then Prometheus itself is a vast topic. You need to understand its expressions and its graphs and all that, but it's pretty simple. So if I say pod, then it will tell me, so it populates with certain values, and I'm going to show you some values that you can use with. And these are some expressions that it will gauge on. So let's see if this gives us the value. So if you say Kubernetes, let's say kube pod IP, so basically I'm saying that I need all of the IPs. So somewhere these are the instance IPs that, no, not these ones. Container name, endpoints, IP, yeah, these ones. So these are the ones that it is giving you back. Now, don't think of these as the IPs of the ones that you are used to. These are the private IPs that the Kubernetes cluster will generate, or the kubeproxy will generate for your cluster, depending on this setup that you have done. And for Grafana, so if you notice, for Prometheus, you don't need any username or credentials, so it just populates. But for Grafana, you need to have username. So let's see, our Grafana is running on this port. Copy that one. Let's put it here. Remove this guy. Paste in. And it is asking us for admin password. They used to give admin as password, but I think now they are giving prom operator as password. No. Admin? No. Okay, awesome. So we will have to take it from the secret object of Grafana. Give me one moment and I will get it. Maybe there is a space that I have mistakenly given. Okay, sorry. It's still prom operator. It's just that I had given one extra space. Okay, and this is how the Grafana dashboard will look like. And in the Grafana dashboard, what happens is there are the most important part for the Grafana dashboard is your data source. So from where are you fetching the values? So let's understand that with an example. Let's say I want a dashboard, and in my dashboard, let's say again, I'm looking for the same thing pod, which I was looking in Prometheus. And here I will say, let's take the first one. Focus here. There is something called a data source and Prometheus, because I only have one data source, so default and Prometheus both are the same thing. Prometheus acts as the provider of the data source to Grafana. And whatever information Prometheus was giving you here in terms of time series, that gets translated in terms of dashboard uh, in Grafana. Now you can have alerts both in Prometheus as well as in Grafana, because those are two different tools. One misconception is that this is one company and one tool. No, these are two different tools which work well together, and that's why people think that this is one tool, but it's actually two different tools and not one tool, which also means that there can be other data source for Grafana. It's not necessarily that only Prometheus is the data source. You can use other tools and technologies available in the market for the Grafana to work, but it works very good with Prometheus. And the one that we are installing, the community version, which I said earlier when I was doing the Helm install, this is the free version of Grafana. There's a paid version as well. Okay, so make sure that you are using the proper versions. Again, these are the apps that we installed, right? So if you go here, you remember that I said, let me duplicate this, new tab, duplicate it, and I will say alias k get pod. Okay, I need to change the context. Now I have three pods, right? These two are coming from the same deployment. This one is for testing, and you can see exactly here. These two are the same ones, which I was highlighting here, and this one is coming from the testing. Because I had to reset the cluster, there is nothing else. But if I change, let's say, cube system, then the list of pods will be changed as well. And there are so many dashboards available in Grafana, and this is not a Grafana and Prometheus tutorial. We just want to understand how they fit in observability context. So I'm not going to go into detailed description, and it's not also possible to do it in one class, because these tools are very heavy in terms of functionality. But in a nutshell, what it provides you is a pictorial representation of the same thing that Prometheus provides you. In fact, Prometheus has something like a graph where it gives an idea of what is happening. And then here you need to write queries, okay? Same thing what I am generating from here in terms of the resources of memory and CPU. You can take exact same thing from Prometheus, but then there you have to write a query command. Here you don't need to write a query command, it is auto generated for you. Okay, so that's a little bit simpler to use. Cool. So let's go back and deploy the main object, which will make the Prometheus understand that it has to scrape the values of our application. So we installed the application, our application had the client, now we have the server also running, we have the dashboard also configured, but there is one key object which is still missing, and that is called SOM object, or service monitoring object. Now service monitoring object will sit on Kubernetes, and this will act as a gatekeeper for Prometheus. So this guy is the one who is going to tell Prometheus what to look for, or what are the endpoints that it has to keep on scraping, so that the custom alerts that we are going to write are going to be evaluated. Without service monitoring objects, nothing of nothing of substance will happen. All of what we said, it requires SOAM objects. SOAM objects are pretty simple to create, and I probably have the most simplest one of them here. So first time, let me show you this one, what it is, and then I will apply it. Configure the service monitoring object. For this to work, the app image needs to be updated. Okay, we already have that image, so that is fine. Let's first of all see where we are. Yeah, so I have it here. I can just open the editor. No, in fact, I have it here as well. So this is the service monitoring object. Like I said, it's a very simple thing, but what is happening here? You are creating a mapping. All right, there are two important parts to this. One is called a endpoint, and another one is called a selector. I have defined endpoint in detail in one of my classes, so make sure that you check it out if you have any doubts with respect to endpoints. Basically, here you are mapping the port with the application selector. That is the label. So you are telling Prometheus to watch for a particular endpoint in a particular interval. Let's say here in my case 30 seconds. In every 30 seconds you go and you check that this guy is giving you a heartbeat with the help of the client that this guy has, and you preserve that and keep it in your database, because like I said, Prometheus is a nothing but a time series database. You preserve it and then you evaluate the custom rules. Okay, if you go here, kubectl, or let's say kubeNS monitoring, and I say k get what is it called, prom, no, not this one, I need the rules. Give me 1 second. K API resources, I think they are called Prometheus rules only. Yeah, prom rules. So k get prom rules. Yes, these are all of the rules that are running right now out of the box. These are not custom rules, these are out of the box rules. And these are going to generate trigger custom alarms here, alerts. So right now there are like 134. I didn't create them. They came out of the box. So there are 134 alerts which are like inactive. You are only concerned about the one that are firing. Firing alert means that these are problems right now. Most of the times this is coming because I have like a single node. Yeah, so you see I have a single node Kubernetes cluster, and that's why they are there. But these are the alerts that will then come to your dashboard in the Grafana. If you go, let's cancel this one. If you go in alerts, these are the same ones. Okay, why is this guy not leaving me? All right, I have to discard it. Then if you go into alerts, and there's a nice video by this guy. I don't know his name, but he has really nicely created a uh, demo for you. Just check it out if you are not aware of these alerts and how to configure them. He has nicely explained. So basically what I'm saying is, whatever you are seeing here as 134, 8 firing, 1 pending, same thing you will see here. Just focus on this one. 8 firing, 135, 134, and then you can customize them. So when, let's say, for example, this alert, right? And then you can have a contact point of view for this person. So whenever this alarm gets created, what I want is like I don't want an email. What I want is, let's say, add a point of contact and then call him or maybe chat him. I don't know why somebody will do that. Or Ops Genie, like I said, you can directly call them on the mobile. So that and all, you can do it from here in this dashboard. All right, let's go back and finish the SOM object. So SOM object is pretty simple, and let's now go and apply this, and that's what you will also do from here. So let's come here. Again, I will do kubectl and kubectl. Oh, I need to first shift my context again to default. Right, and then, oops, I will paste this one. Okay, only this one is created because other ones I created manually in the first step, so they are there as part of HPA. What it will give us is like get SOM. This is the one that it created, and same thing what I was showing you in the code, -o YAML. It is basically going to point the server to the client. So that handshake between the server and the client is getting done by this SOM object. All right, and now comes the interesting bit. Now that you have added this handshake, what will happen in Prometheus is that your server will start showing as a target. Here, right now it's not there. Just give it some time because 30 seconds is the default time. It will start showing as a target for the Prometheus. Earlier, if you do not have a SOM object, it will not come as a target, or it will not even come as a service discoverable object. So here in this list, if you see, all of them are coming from the monitoring namespace. Right? All of them are coming from the monitoring namespace. Our namespace, the default one, is not coming. Now that will show reflecting because we have now done that handshake with the SOM objects. So let's give it some time before it starts scraping the values of our application. So if you have your application, everything is fine, and still your values are not coming, SOM is the culprit. Go and check that out properly. All right, so let's then start. Once that shows up, we will start putting some load. In order to put the load, first let's put the preventive thing in place. So this is the prevention that I was talking about. I don't want an assistant who is not able to uh, self-help itself. If I'm needed all the time, then what's the point of having an assistant? So this is the preventive measure that is in place, where I am saying that, okay, I think 50% is too much. It will take a lot of time to generate that amount of load. So I'm saying that, okay, for my application, if the CPU percentage goes to 30, then you know what, you keep on increasing till 5 pods. But for this, you also create an alert and notify me. This is not actually something that happens in production. I'm just using this as a use case, but you don't need to be notified for auto scaling. Your auto scaling should be smart enough to scale up and scale down anytime the loads are there. But this is just a use case. In general, this can be like a network threshold or stuff like that, but they are difficult to mimic. So I'm taking this example. Otherwise, for don't go and start creating custom alerts for scale up and scale down. You don't need them. They happen all the time. Okay. One classic example would be like there is a database pod and that database pod is not running. So create a color custom alert for that instead of this one. But because this is simple to show in a demo, that's why we are doing this. So let's say 30%. And before running this, we have to make sure that this command is running. Yes, so command is running. It is using only 1 milli cycle of the CPU and 18 of the memory. So what I'm saying is like 10 is the max capacity, and I'm saying 30%. So when this reaches 3 or 4, then you start creating another pod. In fact, let's do one thing. Let's edit the deployment. I don't want two pods. Let's edit this deployment. I just want one pod. Where are you? Yeah. So I will scale it down, right? Right. So then I will hit that command. But before that, let's see if our Prometheus is able to scrape our endpoint or not yet. Okay, after some time, it has come back. Generally takes a little bit of amount of time. If it doesn't work for you, what you need to do is make sure that go to the Prometheus object called prom and make sure that this section is there. If you want to specifically see only uh, your service monitoring object, then you can use this. If you want to see everything, then you can probably even remove this and keep it something like this, where you can just say, let me show it how you should do it. I'm not going to commit it, but I will just show it to you. So here, if it doesn't work for you, you just remove this part and keep it like this, right? I'm not going to commit it. I am going to just keep it there. And then what we want is our endpoint, k get endpoint. This is the endpoint. This particular endpoint should be reflecting in our target. All right, now you can see service monitoring. Now it's not coming from that monitoring namespace. It's coming from the default namespace, and this is your app. As soon as the number of pods keep on increasing, you will see more targets getting registered here, and it's saying that this target is up. It will not work if your SOAM is not configured properly. Okay, now it is registered as a target and it is registered as a discoverable service here. So the handshake between the server and a client is done. Now create the custom rules and also implement the HPA to finish the setup. Okay, now how to create the custom rule? I will give you one example, the simplest one, not the cleanest one, but the simplest one is edit any existing alert. It's the simplest way, okay? So let me take the value from, I think I have done it here. And I'm giving one, this is just a dummy alert, okay? When you are giving the alerts, give the proper alerts. Or if you just want to play it around, you can take the dummy alert that I have created. These are multiple rules that I was playing around with. They are so many, so I will not show them. In our case, we just need this guy here. So let's say I am saying if my CPU usage is more than 10%, perfect. So I will have this one as an expression and I will edit the existing alert. And how to get an existing alert? Okay, get, let me search for it again. I forgot. API resources, and it was called Prometheus rules, I think, right? I keep on forgetting it. Yeah, prom rule. So k get prom rule. Ouch. Monitoring. And let's take the first one. Doesn't really matter because we are just testing it. And let's say k edit this rule and hyphen o no hyphen n monitoring doesn't have this. Okay, I have to again specify prom rule. All right, and I am just going to change the expression. Where is the expression? And here is the expression. So this is what I'm going to change with my expression, this guy. Right, so I'm going to copy this expression. This is the easiest way, like I said, but not a very good way, but that's fine. So, insert, put it here, and then let's say it fails for more than 2 minutes, 1 minute. You trigger the alarm so that we get it quickly done with. And the rule is pretty simple. Let's see it again. Some rate. If you run the same thing in Prometheus, it will still work. Okay. These are the rules that are actually getting evaluated in Prometheus. They are just getting triggered by Grafana. So let's try to see. Hopefully it works in Prometheus. There might be a typo here and there somewhere, but it should work in Prometheus as well. So if I go here and I put this expression here, do I need to have these guys here? Maybe not. Right, so it works. You see the value right now is 11. I am going to trigger the alert for 10. So it will trigger an alert. And what is the name of that alert that is going to be triggered? The name of the alert that is going to be oh no, not this one. The name of the alert that is going to be triggered is no, not you. Name of the alert that is going to be triggered is alert failed reload. Okay, so this is the name. It would probably be still there if you go in alerts, but right now it will not be firing, of course. It would be green because it has a different rule. I am just overriding the rule for this example. Okay, so let me override the rule. It's done. Let me check it again. Yes, severity is critical, and then I save it. I don't need to restart the pod. And then on the other side, what I want to do is I want to trigger the preventive mechanism. And what is the preventive mechanism? Let's go up and put the HPA in place. Okay, so here we go. I am going to put the HPA in place. Instead of 50, I've given 10 there, so that's what it is going to be. And then is the time for putting in load. Now this is our load generator 1. We will generate multiple load. So let's create one pod, started. Let's duplicate it and let's create again load. We will call it load generator 2. Okay, let's create some more load and a default is fine. And we'll call it load generator 3. So now 3 pods are generating the load. HPA is doing the preventive mechanism and reactive, the mail is being set by the alerts. Okay, and that is where this completes the picture. So we have everything in place. Our application is running, users are putting the load, we are having a fallback mechanism, but we are also notifying the customer, and then we will also have dashboards. You see there are connection refuse errors that are coming. This means that some of the messages are getting failed because the load is getting generated. Let's see how it looks. K get pod. So here auto scaling is already in motion. So it has already triggered 2 more pods because I have asked it to scale at the load when the load is more than 10%. So if you can do K top, let's say pods, and then let's grab for anything that has my app. So you see 6, 10, 7, 9. So these are all loads, and I've given it max capacity as 5. So you would probably see one more pod coming in very soon. Yeah, here container is creating, one more pod is coming in because the load is getting generated. So this is the preventive one. Now what about the reactive one? because poor me doesn't know about it yet. So I'm in a meeting and I have to be informed about it. Let's go to the alerting section, alerting rules, and here 10 are firing. Okay, cool. So Prometheus, this one was green earlier. Let's see how it is now. It's blood red, right? So this one is firing and it's saying, hey, there is something wrong because the value is now very high to the rule that you have given. And then based on the connectivity that you are going to create as your connectors for contact policies, you can send a phone call, you can send an email, you can send whatever you want. And this is what Prometheus and Grafana stack provides as a solution for observability in Kubernetes. Okay, the class went a little bit long than I expected, but I hope you understood what I wanted to make you understand. And remember, conceptually, you should be clear. These tools are going to be replaced by the tools in your organization. Uh, Conceptually, the idea will remain the same. You will have an application or stack of application pods which will get the load or get the network throttling happening. For the longer run, you need to have both in place, that is the reactive and preventive mechanisms. But observability will work only when you have both logging as well as dashboarding and monitoring in place. Dashboarding, monitoring, alerting, that is what Grafana is going to give you, and logging is your Datadog, your Graylog, your ELK stack, all of that is your logging. Fluentbit, Fluentd, and all of that stuff is your logging. When you are using Prometheus and Grafana stack, make sure that you're using custom alerts which are specific to your business. All right, I will see you in the next one soon and take care of yourself. Happy New Year. Bye bye.